All right, in today's video we're talking about equivalent ratios. Most of the problems I pulled from today are from the equivalent ratios quiz from Edgenuity. So let's begin. What are equivalent ratios? Equivalent ratios are ratios that make the same comparison. And of course a ratio is a comparison of two quantities. So if you look at the example below, is 9/27 equivalent, not equal to, but equivalent to 1/3? Why, yes it is. Because one way I could prove this is, how do I go from 9 to 1? By dividing by 9. Whatever you do to the numerator, you do to the denominator. So we're going to divide 27 by 9 and we get 3. So they are equivalent. Another way of quickly checking that is to cross multiply. 27 times 1 is 27, and 3 times 9 is 27. So they are equivalent. And so this will look very much like what you did with equivalent fractions in elementary. So the way we solve equivalent ratios or proportions in tables is very similar to that. So let's look at our first problem. The table below shows the amount of money needed to buy certain amounts of fabric. And you see the table, the information, fabric cost, yards of fabric, total cost, and the quantity purchased, and the amount it cost. If the price is the same for each yard, then you don't get a discount if you buy extra, which happens sometimes, but in this problem, it costs the same whether you buy a little or a lot. How much money would 12 yards of fabric cost? And so right here we have a question mark, and just to let you know, most of the time, and a lot of the problems are going to have a variable because it's an unknown quantity. Now it's not always an X, it could be any letter. But I'm going to go ahead and write the variable there because, again, we have an unknown quantity that we are solving for. So there are a lot of different ways we could solve this. I'm going to show you one. First is I'm going to divide my cost. You divide the cost by the quantity purchased. So if I wanted $5.25 worth and I bought 3 yards of fabric, how much is that going to cost me? I can divide this down the 2, 7, 21, bring down the 5, and I'm going to get $1.75. So it's $1.75 for each yard. Now, I want to check to make sure that all of them are the same. So let's try $15.75. Again, divide the dollar amount by the quantity. Let's see if we get $1.75. 0, 1. Bring down the 7. 63. And get 4. Bring down the 5. And then we'll go into 45 5 times. Great. So I'm not going to check the 10, 15, 6. I know that 6 times what equals 10, 15? It's $1.75. So doing this, what this has shown me is, how do I go from 3 to 525, or 6 to 1050, or 9 to 1575? It's times, how do I go from X to Y, times, I'm going to do, since I have a variable, I'm going to multiply, I'll write it out, by $1.75. So, if I multiply 12 by $1.75, what would I get? I would get 21. So my answer to this problem right here is $21. Again, I told you there's multiple ways we could solve this problem. I'm going to show you one more, but really fast. Again, this is a table. This is my X value. This is my Y value, input, output. And then how do I go from X to Y? And regardless whether I pick 3 and 5.25, 6 and $10.50, 9 and $15.75, how do I go from X to Y? By multiplying by 1.75. So 12 times 1.75 is 21, which gave us the answer. Another way we could do it, and this works for everyone, every table, assuming it's linear, proportional, is I can set up a proportion table. So I have yards of fabric, and I have cost. Okay? And so I'm going to do my first one. I'm going to put A here for my first and B for my second. So I have 3 and 5.2. Oh, sorry, that's wrong. A fabric 3, and I get 5.25, $5.25. I'm going to pick 12 here. Why 12? Because 12 is involved with the missing cost. And I'm going to put a variable. Now, when I set up this is a proportion. Okay, I can solve it algebraically. I could cross multiply 3 times x is 3x, and 12 times 5.25 is 63, and 3 times what equals 63? Of course, we already know the answer, and the answer is 21. Or an easier way for this one is, I like setting up tables because usually this will present multiple ways of solving it. I could say, how do I go from 3 to 12 times 4? Whatever you do here, we're going to do here. Okay, and so $5.25 times 4 is that's right, is $21. So again, hopefully I've shown you that there are multiple ways we can solve a problem like this. Find the unit rate, which was $1.75, or set up the table, proportion table, and solve it that way. Okay, our next problem we're going to go over. Vinta is sewing new curtains. The table below shows the relationship between the number of stitches in a row and the length of a row. What is the relationship between the number of stitches and the length? So, again, I'm going to label this X and Y. On this one, we don't have any missing lengths on this one. On this one, we had the X. We were solving for X. On this one, we don't have any missing values. So they're just looking for the rate. How do I go from X to Y? On the previous problem, how did I go from yards of fabric to total cost multiplied by $1.75? So how do I go from 5 to 1, 15 to 3, 20 to 4, 30 to 6? So that's what we're going to be figuring out on this problem. So now obviously there are multiple ways I can look at this. It's a rate, and it's going to be constant, and I can represent this 2 different ways. Now, one way I can do it is, how do I go from 5 to 1, or 15 to 3? Now, a lot of you have great number sense, and I'm sure you realize that I can divide by 5. 5 divided by 5 is 1, 15 divided by 5 is 3, 20 divided by 5 is 4, and 30 divided by 5 is 6. There's also another way we could look at this problem. Is usually when I go from X to Y, I'm multiplying. So how can I go from 5 to 1? So I need to multiply 5 times something, or 15 times something, to equal 3 or 5. How do I go from 5 to 1? So I'm going to do multiplying by something. I'm going to use a variable. I'm not going to use an X. I'll use an N on both of these. Okay, so this is, I'm sure you recognize this is an algebraic equation. This is an easy one-step equation. So how do I go from 5 times what equals 1? So I need to isolate the variable, and again, isolate means to get alone. So what am I doing to the n? I'm multiplying by 5. The inverse, the opposite of multiplying by 5, is dividing by 5. And that cancels out because 5 divided by 5 is 1. And 1 times n is n, because 1 times anything, identity, property, multiplication, stays the same. So whatever you do to the left side, got to keep it balanced, I do to the right side. And so once I'm there, I can turn that into a decimal, but it is a ratio. I'm going to keep it like that. How do I go from 5 to 1? I multiply by 1/5. So how do I go from x to y by multiplying by 1/5? I'm sure you can say, hey, I'm dividing by 5. It's the same thing because this is a unit fraction. So technically, I'm multiplying by 1/5. Does it work the same on this one? 15 times what equals 3? Need to isolate the variable. Multiplying by 15. The inverse is dividing by 15. And 15 divided by 15 is 1. 1 times n is n. Whatever I do to the left side, that's right, I do to the right side. And of course, you simplify 3 over 15. That's right, you get 1/5. So, when they're looking for the relationship, what is the relationship between the number of stitches and the length? There are 5 stitches and 1 centimeter. Or you could say, how do I go from 5 to 1? It depends upon how they ask the question. You can say you're dividing by 5, or you could say you're multiplying by 1/5. All of those would be correct. So, let's look at the last problem. The ratio table below shows the number of eggs per omelet. How many omelets can be made with 18 eggs? So, what we're going to do is x input, output. I put in eggs into a pan, and out comes an omelet. So this is definitely my input, and my output is a nice, tasty omelet. So on this, I'm going to put a variable here because there should be a variable because it's an unknown quantity, which I'm looking for. And of course, I'm asking myself, how do I go from x to y? How do I go from 3 to 1, 6 to 2, 9 to 3? Now this one's easy because I'm dividing by 3. How do I go from 9 to 3? Divide by 3. 6 to 2, divide by 3. 3 to 1, divide by 3. Or, again, we can say I'm multiplying by 1/3. What's 9 times 1/3? Which is 9 over 3. You simplify 9 over 3, and you get 3. What's 6 times 1/3? That's right, 2. Or 3 times 1/3, and you get 1. Once I know this, I can plug 18 in. And so 18 divided by 3, or 18 times 1/3, I'm going to get 18 over 3, which simplified equals 6, and that is my answer. All right, so hopefully this has helped in solving for unknown values in a table or finding the rate. How do you go from x to y? And I know you've done this in 5th grade. In 6th grade, the problems are going to look very similar to what you did in 5th grade. Just sometimes the number are a little less pretty. We're dealing with more rational forms or forms of rational numbers and irrational numbers. So again, what are equivalent ratios? Equivalent ratios are ratios that make the same comparison. Treat them, a lot of times you can treat them like equivalent fractions. How did you find those? In elementary school, whatever you do the top, you do the bottom. Sometimes we can cross multiply. And on these, again, just look for that rate and you'll find them. Hopefully this has helped. If you have any additional questions, you can email me at jhewlett@leisd.ws. Thanks and have a great day.